Okay, so now what we're going to do is we're going to take a look at when they ask us to work backwards. And the thing that makes us know that we're working backwards is because they're asking for the initial deposit that you would need to come out with this much money at the end. So the problem says how much money needs to be deposited into an account that earns 4% annual interest compounded monthly to have a balance of 5,000 after 5 years. So this is what the 5,000 is, what the outcome is. So the reason why we call it working backwards is because we need to figure out what the initial amount needs to be. Like, how much do I have to put in the bank to get $5,000 in the bank after 5 years if I'm compounding monthly at 4% interest? So in order to do this one, you definitely need a calculator. We're going to set up our growth formula, which is A of t equals A naught 1 plus R over 12. Remember, we're compounding monthly, so you have to divide by 12. And then t times 12 because we're compounding monthly. So you're going to multiply by 12. Those are the two things that you have to modify for your regular growth formula. Then we can start plugging in all the stuff we know. The thing that messes people up is the 5,000. 5,000 is our outcome. That's what it's going to be equal to. So 5,000 comes over here. We're trying to figure out our initial investment. We don't know what A naught is, so we're going to just leave that as A naught. This is 1 plus, the rate is 4%, so we're going to change that to a decimal, 0.04 divided by 12, and the time frame they wanted was 5 years, so we need 5 times 12. Okay, so we're solving for A naught. That's what we're looking for, the initial investment. So we've got to clean this up a bit. So let's check this out. So I'm going to, in my calculator, do 0.04 divided by 12. Then I'm going to add 1, and I'm going to write down this whole big daddy, 1.00. And then 1, 2, 3, 4, 5, 6, 7. That's a lot of threes. But that's what you should see on your calculator when you do it. And 5 times 12 is 60. So this whole number needs to be raised to the 60th power. So if you keep it in your calculator, look at mine. If you keep this in your calculator, and you just hit the caret and the 60, you'll get the number that you need. So this is the one that you're going to put down as what this evaluates to. So 1.22096594. I really don't want to round, only because I don't know what place value is going to actually change stuff up. So I write them all down. It's not that hard to copy them. Now, this is all, like, the exponent is done. The inside the parentheses is done. So this is truly and honestly just a multiplication now. So you know how to solve this. In order to undo a multiplication, you've got to divide. So we're going to divide both sides by 1.2209965994. That cancels with that, and we will get our initial investment. Now, it's not going to divide clean, meaning that there are going to be some decimal values, but we're talking about money. So we got to use reasonableness. So this is what we end up with, $4,095.02. If you want to put the cents there. Dollars and cents. That's how much it would take to get $5,000 in the bank after 5 years, compounded monthly with 4% interest. So again, the difference between the first set of examples and this is that we're working backwards. Here, they give us the outcome. Like, I want to have $50,000 in the bank in 30 years. What do I have to start with? This is how you would solve that out. Okay, so this is your answer. We would need to begin with $4,095.02, and that would give us $5,000 in 5 years.